In the desert, metal rusts. Wood rots. Plastic melts. But bone endures. The Bedouins knew this truth better than anyone. Every animal that died became a toolkit waiting to be unlocked. Camel bones. Goat bones. Sheep bones. Even the delicate skeletons of desert birds had their purpose. Death in the desert wasn't an ending. It was a transformation into something useful. The moment an animal died, the clock started ticking. Not for decay, for opportunity. The Bedouins moved fast, but with precision. Every bone had to be cleaned properly, dried correctly, and stored safely. Miss a step, and the bone would crack, split, or become too brittle to work. Get it right, and you had tools that could last for decades. The femur of a large camel became the foundation of their toolkit. Cleaned and dried, it transformed into a hammer heavy enough to drive tint stakes into hard-packed sand. The hollow interior was perfect for storing small items, needles, precious metal pieces, medicines. The joint ends, rounded and smooth, became pestles for grinding grain and spices. Rib bones held different possibilities. Long, curved, and naturally flexible when fresh, they could be split lengthwise with a sharp stone. Each rib yielded 2 or 3 needle blanks. The Bedouins would carefully scrape away the spongy interior, leaving only the dense outer layer. Then came the delicate work, tapering one end to a point fine enough to pierce leather, boring a tiny hole at the other end for thread. These bone needles weren't crude substitutes for metal. They were often superior, lighter than steel, smoother than iron, and they never rusted in the humid air near oases. A master craftsman could create needles so fine they could sew silk, so strong they could pierce thick hide without bending. The shoulder blade became a shovel, its broad, flat surface perfect for moving sand, digging fire pits, or scraping animal hides clean. The spine of the blade, naturally reinforced, served as a handle. No assembly required. No joints to fail. Just a single piece of bone, shaped by millions of years of evolution into the perfect digging tool. But the real artistry came with the smaller bones. Toe bones became buttons, drilled with tiny holes and polished until they gleamed. Finger bones transformed into beads for trade or decoration. Even the smallest fragments found purpose. Splinters became toothpicks. Chips became scrapers for cleaning under fingernails or removing thorns from skin. The skull held special value. The brain case, cleaned and hollowed, became a bowl for water or food. The eye sockets, perfectly sized, held precious oils or medicines. The nasal cavity could store salt or dried herbs. Nothing was wasted. Every curve and hollow had been tested by countless generations of desert dwellers. Stone was everywhere in the desert, but useful stone was rare. The Bedouins developed an eye for quality that would impress modern geologists. They could spot good flint from 50 meters away, judge the hardness of granite with a glance, identify workable limestone by its color and texture. Flint was the prize. This volcanic glass could be knapped into blades sharper than surgical steel. But it had to be the right kind of flint, free of cracks, dense throughout, with the proper grain structure. Bad flint shattered unpredictably. Good flint broke exactly where you wanted it to break. The knapping process was part science, part art. The master craftsman would study a piece of flint for minutes before making the first strike. He could see the internal structure, predict the fracture lines, envision the finished blade. The striking stone had to be harder than the flint. Usually a piece of iron-rich rock that rang like a bell when tapped. The first blow created the basic shape. Subsequent strikes refined the edge, controlled the thickness, adjusted the balance. A skilled knapper could predict exactly where each chip would fall. His workspace would be covered with flakes of specific sizes, some destined to become arrowheads, others scrapers, still others cutting edges for composite tools. Sandstone served a different purpose entirely. Its abrasive surface was perfect for sharpening other tools. Different grades of sandstone produced different levels of polish. Coarse stone for rough shaping. Fine stone for final edges. The smoothest sandstone, worn by wind and water, could polish bone needles to a mirror finish. Limestone became their marking system. Soft enough to leave visible marks on rock or hard-packed sand. It served as chalk for marking trails, boundaries, or messages. Different colors of limestone created a basic communication system. White for safe water, red for danger, yellow for hidden supplies. The tools themselves were often composite creations. A cutting implement might combine a flint blade, a bone handle, and sinew binding. The blade provided the cutting edge. The bone offered lightness and comfort. The sinew held everything together with a grip that actually tightened when wet. These weren't temporary solutions waiting for better materials. They were permanent technologies, refined over centuries of use. A bone needle could be resharpened dozens of times. A stone blade could be re-knapped when it dulled. A composite tool could be repaired in the field with materials found anywhere in the desert. The knowledge of working bone and stone wasn't written down. It was encoded in muscle memory. Children learned by watching, then by trying, then by making mistakes and trying again. By adolescence, they could identify useful materials at a glance. By adulthood, they could craft basic tools with their eyes closed. This wasn't primitive technology. It was appropriate technology. Tools designed specifically for a nomadic lifestyle in one of Earth's harshest environments. Light enough to carry, durable enough to last, simple enough to repair, and made from materials that were everywhere, free for the taking, if you knew how to see them. The art of transformation. Animal hides weren't just protective covering. They were the raw material for an entire civilization. Every skin told a story of transformation that would humble modern recycling programs. A single goat hide might serve as clothing for years, then become a water container, then rope, then patches for other equipment, and finally, when completely worn out, return to the desert as compost for the few plants hardy enough to grow in such conditions. The process began the moment an animal died. Timing was everything. Wait too long, and bacteria would begin breaking down the proteins that made the hide useful. Move too fast, and you damage the skin during removal. The Bedouins had perfected a technique that preserved every usable square inch. The first step was careful skinning. A sharp stone blade, guided by experienced hands, separated the hide from the carcass in one continuous piece. The cuts followed natural lines, around joints, along muscle groups, avoiding areas where the blade might punch through. A master could skin a goat in less than 10 minutes and produce a hide with no holes, no tears, no weak spots. Fresh hide was useless, soft, perishable, prone to rot. The transformation required salt, ash, and patience. Desert salt was abundant near dried lake beds. Ash came from burning dried dung or certain desert plants. The hide was stretched on a wooden frame, rubbed thoroughly with the salt ash mixture, then left to cure in the desert sun. The sun did most of the work. Its intense heat and ultraviolet radiation killed bacteria and broke down the proteins that caused decay. But too much sun would make the hide brittle. Too little would leave it vulnerable to rot. The timing had to be perfect, usually 3 to 5 days, depending on humidity and temperature. The cured hide emerged transformed. No longer skin, now leather. Flexible but strong. Water-resistant but breathable. And ready for its first life as a functional tool. Large hides became water containers. The famous burdock could hold 20 liters and keep that water cool through evaporation. The construction was ingenious. The hide was turned inside out, with the hair facing inward. The natural oils in the hair helped seal small pores. The exterior was treated with plant resins that made it nearly waterproof. The neck opening was reinforced with strips of sinew and sealed with a wooden stopper wrapped in cloth. The result was a flexible water tank that weighed almost nothing when empty, could be squeezed flat for transport, and actually improved the taste of water through its natural filtration properties. The medium-sized pieces became cooking vessels. This seems impossible. Leather should burn when exposed to fire. But the Bedouins understood the physics of heat transfer. A hide container filled with water could be placed directly on coals without burning. The water absorbed the heat, keeping the leather at safe temperatures. This technique allowed for true cooking, stews, soups, boiled grains, without metal pots. Heated stones were dropped into the water to bring it to a boil. Different stones produced different cooking temperatures. The cook controlled the heat by adding or removing stones, just like adjusting a burner on a modern stove. Smaller pieces became bowls, cups, and food storage containers. The natural shape of certain hide sections, like the area around the shoulder blade, created perfect bowl formations. These containers were lightweight, unbreakable, and naturally antibacterial due to the tanning process. But perhaps the most impressive transformation was hide into rope. The process began with cutting the hide into one continuous spiral strip, starting from the outside edge and working inward. A skilled craftsman could produce a single strip 30 meters long from one medium-sized hide. The strips were then processed further, scraped to uniform thickness, soaked in water until pliable, twisted while damp into tight spirals. 3 twisted strips were then braided together, creating rope with incredible tensile strength. This rope could hold the weight of a fully loaded camel, resist fraying from sand and wind, and last for years of constant use. The hair wasn't discarded. Goat hair was particularly valuable. Each fiber was strong, water-resistant, and naturally crimped for spinning. Collected hair was sorted by length and color, then spun into thread using simple drop spindles made from bone and stone. This thread became the foundation of Bedouin textile work. Tent fabric, clothing, blankets, saddlecloths, all woven from hair that would otherwise be waste. The thread was stronger than plant fibers, more durable than cotton, and naturally resistant to the desert's harsh conditions. Even the shortest hair fibers found purpose. Mixed with clay and water, they created a reinforced mortar for building temporary shelters. The hair acted like modern rebar, preventing cracks and adding structural strength. Walls built with hair-reinforced clay could withstand sandstorms that would demolish pure mud construction. Sinew, the tough connective tissue from animal joints, became the finest thread available. Dried and split into individual fibers, sinew was nearly invisible but incredibly strong. Perfect for detailed sewing work, repairing tears in valuable fabric, or creating fishing line for the occasional desert pool. The fat and oils weren't wasted either. Rendered animal fat became waterproofing for leather goods, fuel for lamps, and base material for soap when mixed with plant ash. Brain tissue, properly processed, created a natural leather conditioner that kept hides flexible and water-resistant for years. This wasn't simple recycling, it was total material utilization. Every part of every animal had multiple uses, backup applications, and final disposal strategies. The Bedouins had created a circular economy thousands of years before the term was invented. Nothing was waste because waste was a concept they couldn't afford. Weaving and woodwork. In a landscape of endless sand and scattered stone, wood was more precious than gold. Every scrap of timber told a story of survival, careful planning, and ingenious adaptation. Dead trees were landmarks, marking their locations in mental maps passed down through generations. Driftwood from ancient floods was treasure to be carried for hundreds of kilometers. Even the smallest twig was collected, evaluated, and either used immediately or carefully stored for future need. Palm trees represented the jackpot of desert forestry. When a palm died, from age, disease, or drought, the entire tribe would mobilize to harvest every usable part. The massive trunk, sometimes 10 meters tall and a meter thick, became the foundation for multiple construction projects. But accessing this treasure required planning, teamwork, and specialized knowledge passed down through generations. The trunk had to be processed immediately. Desert heat and insects would attack dead wood within hours, making it brittle and unusable. The Bedouins had developed techniques for rapid breakdown that maximized yield while minimizing waste. Long stone blades split the trunk along natural grain lines. Bone wedges separated the pieces without creating the fractures that metal tools might cause. The outer layer of the trunk, dense and hard from years of desert exposure, became structural elements, tent poles, digging sticks, and handles for heavy tools. The softer interior was hollowed out to create containers. A single palm trunk could yield water storage vessels holding 50 liters or more. These wooden tanks were lighter than pottery, more durable than hide, and could be sealed with plant resins to become completely watertight. But the real artistry came in working smaller pieces. Palm wood was fibrous and difficult to cut, but Bedouin craftsmen had learned to work with the grain rather than against it. They would study a piece for long minutes, identifying the natural stress lines and weak points. Then, using controlled pressure rather than force, they would split the wood exactly where they wanted it to separate. The fronds provided different opportunities entirely. Fresh fronds were green and flexible, perfect for weaving. Dried fronds became construction material. The technique for harvesting required careful timing. Too early, and the fronds were too soft and would rot. Too late, and they became brittle and unusable. Each frond was processed into strips of various widths. The central spine became a rigid support element. The side sections were split into progressively thinner strips, some as fine as thread, others as wide as ribbons. Different widths served different purposes in the weaving process. The weaving itself was done without looms in the traditional sense. Instead, the Bedouins created temporary frameworks using tent stakes, camel bones, or even their own hands and feet. The technique allowed for incredible portability. A weaver could set up anywhere and begin work immediately. Baskets were woven so tightly they could hold water like pottery vessels. The technique involved multiple layers, a structural foundation for strength, a middle layer for flexibility, and an outer layer for water resistance. The fibers were wetted during weaving, then allowed to dry and shrink, creating a surface so dense that liquid couldn't penetrate. These weren't simple containers. Different weaving patterns created different functional properties. Open weaves allowed airflow for storing grain or dried fruits. Tight weaves created watertight storage. Special patterns incorporated natural dyes to create identification marks or decorative elements. Mats were woven for multiple purposes. Sleeping mats had different characteristics than floor covering. Prayer mats required specific dimensions and patterns. Work mats needed durability above all else. Each type of mat required different techniques, different materials, and different levels of craftsmanship. The most impressive mats were the large tent floor coverings, woven in sections that could be transported separately then assembled on site. These mats could cover areas of 50 square meters or more. The weaving was so precise that the sections joined together seamlessly, creating a floor surface that was waterproof, insect-resistant, and comfortable to sit or sleep on. But Bedouin woodworking went far beyond simple splitting and weaving. They had mastered the art of shaping wood through controlled moisture and pressure. Green branches could be bent while still alive and flexible, then held in position with bindings until they dried in their new shape. This technique created curved handles that fit the human hand perfectly, bent tent stakes that drove into sand more easily than straight ones. Specialized tools with angles and curves that would be impossible to create through cutting alone. The wood retained its strength because the grain wasn't broken, it was simply redirected. Joining techniques were equally sophisticated. Without nails or screws, the Bedouins relied on mechanical connections that were often stronger than modern fasteners. Mortise and tenon joints held together without glue. Lashing techniques using sinew or plant fiber created flexible connections that could absorb stress without breaking. Complex tools were assembled from multiple pieces, each optimized for its specific function. A digging stick might combine a hardwood point, a softwood handle, and a bone or stone weight for balance. The assembly could be disassembled for transport, repaired if damaged, or modified for different tasks. The knowledge of wood properties was encyclopedic. Which species worked best for different applications? How to identify wood quality by color, smell, and weight? How long different woods needed to season before use? Which combinations of woods created the strongest composite tools? This knowledge wasn't written down. It was embedded in the muscle memory of generations. Children learned by watching adults work, gradually absorbing the subtle techniques that separated master craftsmen from beginners. By adulthood, they could evaluate a piece of wood at a glance and envision multiple possible finished products. Storage of wooden materials required its own expertise. Wood had to be protected from insects, moisture, and extreme temperature changes. Different storage methods worked for different types of wood. Some pieces were buried in sand. Others were suspended in the dry air of tent peaks. Still others were treated with oils or resins to prevent degradation. Fire, clay, and alchemy. Fire was the great transformer in Bedouin society. More than warmth or light, it was their foundry, their laboratory, their pharmacy, and their workshop. With nothing but flame and accumulated knowledge spanning centuries, they could transform the raw materials of the desert into finished goods that would challenge modern manufacturing. The mastery of fire wasn't about burning things. It was about controlling heat with surgical precision. Clay was scarce in the deep desert, but when found, it represented unlimited potential. Not the rich, plastic clay of river valleys, but the scattered deposits left by ancient floods or the sparse accumulations near seasonal water sources. Every handful was precious. Every piece had to be tested, processed, and used with maximum efficiency. The testing process was crucial. Desert clay often contained salt, sand, or other impurities that could ruin a finished piece. The Bedouins had developed a rapid assessment technique. A small test piece was shaped, dried, and fired in minutes. The way it cracked, the sound it made when tapped, the color it turned. All these factors revealed the clay's properties and potential uses. Good clay was processed immediately. Impurities were removed by hand, grain by grain. The clay was then mixed with carefully selected additives. Chopped plant fiber prevented cracking during drying. Crushed pottery shards from broken vessels added strength and reduced shrinkage. Sand provided texture and helped control the firing temperature. The mixing process was done entirely by hand and foot. Bedouin potters would knead the clay like bread dough, feeling for lumps, air pockets, or inconsistencies in texture. The process could take hours for a large batch, but it was essential for producing pottery that could survive the thermal shock of desert use. Shaping was done without pottery wheels, a luxury that nomadic people couldn't carry. Instead, the Bedouins used the coil method, building vessels from long snakes of clay spiraled upward from a flat base. Each coil was carefully joined to the previous one, smoothed both inside and outside, and shaped to create the desired profile. The technique allowed for incredible variety. Water jars with narrow necks to minimize evaporation. Wide bowls for food preparation. Specialized shapes for storing different materials. Each form was optimized for its specific function, with wall thickness, shape, and size all carefully calculated. But the real skill came in the firing process. Without kilns, the Bedouins had to create controlled combustion environments using whatever fuel was available. Dried camel dung was the preferred material. It burned steadily, produced even heat, and created the reducing atmosphere that gave their pottery its characteristic dark color. The firing pit was dug with precision. Too shallow, and the heat would escape. Too deep, and the pottery might crack from uneven heating. The vessels were arranged carefully, with larger pieces on the bottom and smaller ones nested inside or stacked on top. Everything was covered with a layer of pottery shards, then buried under the fuel. Lighting the fire required patience. Too much heat too quickly would cause the pottery to explode. Too little heat wouldn't complete the chemical transformation that turned clay into ceramic. The fire had to be fed constantly but carefully, maintaining the right temperature for 8 to 12 hours. The master potter could judge the progress by the color and character of the smoke, the sound of the burning fuel, and even the smell of the fire. When the firing was complete, the pit was sealed and left to cool slowly. Rapid cooling would crack every piece. The finished pottery was rough by modern standards, but perfectly adapted to desert life. The porous surface allowed water to evaporate, cooling the contents. The thick walls resisted thermal shock. The dark color absorbed heat efficiently for cooking vessels. And when pieces broke, which they inevitably did, the shards became tools, scrapers, and raw material for the next batch of pottery. But clay work was just one aspect of desert alchemy. The Bedouins had identified dozens of plants with special properties when burned, processed, or combined with other materials. This knowledge was closely guarded, passed down through families, and often specialized by region and tribe. Certain desert plants, when burned to ash, produced alkali-rich residue that could be mixed with animal fat to create soap. Other plants yielded dyes, reds from iron-rich roots, yellows from certain flowers, blues from rare berry-producing shrubs. Still others produced medicines, preservatives, or materials for waterproofing. The processing techniques were sophisticated chemistry, performed without understanding the underlying science, but with perfect practical knowledge of cause and effect. Plants were harvested at specific times of year when their chemical content was optimal. Different parts of the same plant, roots, leaves, stems, flowers, were processed separately because they contained different active compounds. Extraction methods varied by plant and desired product. Some materials were simply dried and ground to powder. Others were boiled in water to extract soluble compounds. Still others were fermented in buried pots for weeks or months to develop their properties. The most valuable preparations were compound medicines, mixtures of multiple plant extracts that worked together to treat specific conditions. These formulations were the result of generations of trial and error, refined through careful observation of what worked and what didn't. Metalworking was limited but not non-existent. Small pieces of iron could be obtained through trade, found as meteorites, or scavenged from abandoned settlements. The Bedouins couldn't smelt ore, but they could reshape existing metal using heat, and simple tools. The forge was a shallow pit lined with stones, fed by bellows made from animal hides. The heat source was charcoal, produced by carefully controlled burning of the densest available wood. The temperature could reach 1,000 degrees Celsius, hot enough to make iron malleable and allow for basic shaping. Tools were repaired rather than manufactured. Broken knife blades were reshaped into smaller tools. Worn metal edges were sharpened and rehafted. Bent implements were straightened. Nothing metal was ever discarded. It was simply transformed into something else. But perhaps the most impressive aspect of Bedouin fire mastery was their control of combustion itself. Different materials produced different types of fire. Fast burning for quick heat, slow burning for cooking, smoky fires for signaling, nearly smokeless fires for concealment. They understood how moisture content affected burning rate, how airflow controlled temperature, how different arrangements of fuel created different flame characteristics. A Bedouin fire tender could maintain a cooking fire for hours with minimal fuel, or create an intense blast of heat that could be seen for kilometers. This wasn't primitive firemaking. It was precision combustion engineering. Every flame had a purpose. Every fuel choice was deliberate. Every fire was built to accomplish specific goals with maximum efficiency and minimum waste. Fire wasn't just a tool. It was a partner in the endless work of transforming the desert's raw materials into the tools and equipment necessary for survival.